Today, we're going to introduce HSA with multi-WAN, particularly to load balance multiple fixed line ISP together with mobile LTE connections. If you have attended our Lab 1 or Demo 1 in previous session, we have already covered load balancing dual LTE together with one fixed ISP. And in this lab, we're going to cover two ISP together with two LTE. And of course, it's optional to have LTE, but we do have a lot of queries where customers are using a single HSA together with multiple ISP, fixed line ISP links. So in this lab, we're going to introduce configuring the ISP links into two groups. Group 1 is using the fixed line, so they'll do active-active, that means bonding between the fixed line. Then group 2 will be LTE, active-active between the LTE lines. Then if all the ISP links fail, then the connection will fail over to LTE connections. So it's optional whether you have LTE as backup or not, but it's possible to have two fixed ISP links or multiple ISP links to load balance by HSA. So if you look at our HSA design, hardware design, there's really one physical WAN port. So there's always a misperception that HSA can only use one ISP links because there's only one WAN port connecting to ISP. But the fact is, we can actually configure any one of the LAN port as a WAN to link to the ISP. Then we can load balance, or rather we can do bonding between the ISP links. So I'm going to continue the lab from our early demo. So I'll just download the configuration. And I've already added the device to mFusion. So I'm just going to push the configuration from demo 1 and just going to make some simple configuration to add in additional links for ISP 2. So I'm just going to upload the ISP link. Sorry, the previous config. So once you upload the config, I'll just push to the device. So just wait for the config push to happen. I've already consoled to the box. So once it grabs the config, it will automatically reboot. So while we're waiting for the reboot to happen, I'll just explain a bit of concept on how we achieve multiple physical ISP links load balancing using HSA when it really just have one physical WAN port. So we just configure one of the LAN port into a VLAN. So that means because these 4 ports are switch ports, but we can configure VLAN among the switch ports. Then we assign one of the physical port to the target VLAN. Then we use the VLAN as the WAN port. So this is what we're trying to achieve. So that means, for example, ISP1 is actually connecting to the physical WAN port. Then ISP2 will connect to the LAN port. This LAN port is assigned to a VLAN. So the IP address and everything will be assigned to the VLAN interface. Then we're just going to add the VLAN interface into the bonding group or other multi-WAN group. And optionally, we can continue to use the LTE. If you have the dual LTE SIM model, then we can do load balancing across 4 ISP connections. If you have another ISP, for example, you just create another VLAN and assign another LAN port into the VLAN and configure VLAN interface for the VLAN as a WAN port. So we just wait for the config push to happen. And before that, just make sure the LTE is ready online with the default config. It's really a default config because I did a write erase. If you look at the logs, okay, the logs are ready for. So we just wait for this config push to happen. Once the config push has happened, then we will use the LAN, my PC to connect to the HSA UI to make the additional config change. Or you can actually make changes from the Enfusion portal. If you're familiar with the HSA configuration syntax using HSA config editor. So to make that simple, for this demo purpose, we'll use the UI. So what I'll do is I've already connect my PC to 192.168.1.1. So if you just double check the main interface is 192.168.1.1. So I'll just connect to the UI using that IP address. So at this stage is a default config. The default config comes with LTE 0 and LTE 1. It's already slotting the SIM card, so the connection is up, and with a LAN port. So if you look at the demo one, we actually have configured a VLAN into VLAN, and we have also broadcast an SSID for us to test the captive portal and Wi-Fi connections. So if you're not familiar with this lab, please do spend time to go through this demo, because demo 2 is actually continuation from demo 1. So just going to make simple configuration from demo 1 config. And the config push can take as much as 10 minutes. And if you just want to verify, just do a few simple verification. And I can pin portal.ransnet.com, which is the Enfusion portal, and just make sure if you are using your private Enfusion, you need to configure IP host portal.ransnet.com to point to your own Enfusion IP address, because I'm using my default cloud Enfusion portal to push the config. So I don't need to do anything here. Just need to make sure I can pin portal.ransnet.com and it's pointing to my actual Enfusion IP address. And also I have already verified Enfusion agent is running. So the config push can take as far as 10 minutes, because every 10 minutes Enfusion if the agent on the device will try to contact the Enfusion server to see whether there's any config push instructions. I've just loaded that a short while ago, so we just wait for that to happen. So while we're waiting for this to happen, you can actually see that after I loading the upload the config from my backup, it is actually audit on what time the config was loaded in and who loaded it. And you can also compare the config difference between the config that we have just loaded and the original config loaded in from the box. So you can actually verify the config difference using the editor. So on the left is the config that we push, and on the right is the auto backup. The auto backup is just the last auto backup is really the default config. Once the box detects any config change, you will do an auto backup and you will keep the last 3 auto backup configs. So ever since it was online about half an hour ago, there hasn't been any change. So there's really just one auto backup. So later, if you make changes to the config, you will see the box will auto backup the differences, or rather the new config. You can compare the differences again. And as we speak, just now, the box has already grabbed the config and already from here, you already started to reboot. So once it reboots up, you will actually load in the config that we have just pushed down from here, and we can verify from the UI again later. We can also do some testing to make sure whatever change we have pushed in from demo 1 works as expected, as per demo 1 that we have used before. Just getting my phone ready to do the test. And again, we're going to add in a new ISP link assigned to a VLAN for the LAN port, and assign IP address to the VLAN interface and add it into the multi-WAN configuration. So you'll see how it would be extremely simple for the additional config. Okay, the box is pretty much boot up. Once you see the GSM module and everything, that means it's ready boot up. You can verify a bit of from the command line. The command line access is optional. just for the lab purpose, I will just verify this. You can show the hotspot is running, and we have loading the hotspot config from the backup. And if you look at the UI, is actually in our previous demo there was a Vlan 10, and Vlan 10 was actually binded to the SSID, the two wireless SSID, Vlan 10, and we have enabled hotspot on Vlan 10. So that means if I use my phone to connect to the hotspot, I should get the captive portal, and we can start to log in and verify that as well. Just to check my SSIDs here, and box Wi-Fi Vlan 10. I can see the captive portal. On the right is my screen, my phone screen. I can click to access. So I get access. That means it's working. The restore from the previous lab config is working fine. You can verify, and this is my device. This is my IP address and a device. So now we're going to add in another ISP link to one of the LAN port. So what we need to do is we need to configure, remember, we need to configure VLAN to map to the LAN port. So just going to VLAN 100. But the previous, previous lab, this port is actually my management port. The port 1 is actually connecting to my PC to access the UI. The other 3 ports are assigned to VLAN 10 to be the same as the Wi-Fi VLAN. So what I'll do is I'll use port 4 to assign to VLAN 100 so that I can connect this to another ISP. Just turn it off. And save and apply. So this has just configured a VLAN and assigned one of the LAN port to this VLAN. So now the next step is to configure the VLAN interface. And this interface is going to be my WAN interface, which will participate in the multi-WAN configuration. So I need to create a VLAN interface. You can configure static or DHCP, depends on your ISP offering. If it is a static, you can select static option. For me, I'm connecting to a DHCP ISP connection, so I just select DHCP. So here is the trick. We need to have ETH1.100. The 100 is actually the VLAN ID. ETH1 is mapping to the LAN side of the network. If you look at the WAN is actually ETH0. That's on the traditional WAN side of the network. So just make sure it is ETH1.100 and submit. And also remember to assign this port to be in the WAN firewall zone, so we don't have to change the firewall zone, because the firewall zone already allows LAN to WAN, so we don't have to modify anything. The LTE connection is on the WAN zone as well. And to participate in multi-WAN, remember, we need to change the interface metric setting to make sure it has a unique metric setting as well. And VLAN 100 is there. It gets IP address from the ISP links. So we got 2 connection, ISP WAN. This WAN port is connected to ISP 1, and VLAN 10 or VLAN 100 is connected to ISP 2, and both are getting IP address. And LTE 1 and 2 are also getting its IP address. That means the SIM cards are working well. And if you don't have LTE 0 and 1, that means if you're just using 2 ISP links, it's fine. So now I'm going to bring this VLAN 100 to participate in the multi-WAN configuration. So I just need to set the metric setting. You can set any gateway metric as long as it's unique. Just wait for the config change to apply. So once you're done, we are ready to go on with the load balancing. In our previous lab, we already have configured ETH0 and LTE 0 and 1 and WAN to participate in the multi-WAN load balancing. So now we just add in the VLAN 100. The VLAN 100 naming must be the same as the one that you see on the interface. If you look at the interface, we use VLAN 100. So here we just have to make sure it's the same. Otherwise, you will not be recognized automatically. So you can track any IP address, or I'll just track my default gateway. Pin count and interval is really just for you to determine how reliable the connection is. If you want it to be shorter and faster, you can set it to be quicker and lesser pin count to detect the failure. But for me, I just wanted to reduce the flapping, so make the pin count higher and timeout to be longer as well. So you auto detect the gateway metrics. If you get an error here, it shows that there's no metric value for this interface. That means you didn't set it at the interface level. So now everything looks good, no error. So we're going to move on to the next one. So we just bring the interface to participate in the M1 member. So you can give any name, just make sure it's readable. So one point to take note here is, if you look at the LT interfaces, we give metric 2 and WAN as 1. That means this is lower metric value. That means this will be active. So these two will be standby. But between these two, they will do load balancing. That means if the WAN fail, both WAN link fail, the LT, both LT will take over and they will do load balancing or bonding between the LT interface. So we just bring, and because I'm going to do the bonding or active-active between the two fixed line ISP links, so I will set it to have the same metric as the other ISP links. So now, summary again, both are value 1. That means these two will do active-active. Same weight, that means will be do load share. That means they have the same weightage, 50%, when both of them are active. Similarly for LT 0 and 1, that means these two, because it's lower metric, they're in a group 2 having lower metric value, they will be backup. This group will be backup to the WAN groups. And if you don't have LT, you can ignore this too, or you can just simply delete them. And policy, you can give a name. That means how you want to do the failover. I would just delete this one because the naming in my previous config was too long. So I just added a new policy. I would just add in the members. And last resort, you'll still use the routing table so it doesn't block traffic. So under the rules, you determine how you're going to do the traffic flow. So if you just put everything 0, that means by default, everything will participate in the load balancing as per the algorithm that we configure here. You can also do policy-based routing. That means you can force certain group of traffic based on source or destination, or even based on application port, to have different policies. So here, I'm just going to do a default. That means all will follow the policy that we have defined here. So essentially, again, this group active. And if both ISP links fail, LT2 will take over. And between these two LT, they will do active-active. So we are done for the multi-WAN configuration. So now all of them are up and running. So if you check the status, we really have these two WAN ports are running because these two are having the same metric lower than the LT, and these two are doing active-active because they have the same metric, they have the same weightage. So if one of the interfaces is assigned with higher weightage, it will have, you will be carry more traffic. So we are pretty much ready to do the testing. And before that, because we changed the added a link, added the load balancing rules and everything, it's always recommended to restart the hotspot if you have a hotspot configuration. stop and start. Show security hotspot. Okay, so it's running, and just show interface. Have a tunnel interface. This tunnel is really the hotspot server IP address. So I'm just ready to do the test again. So just restart my Wi-Fi. Connect to the SSID. Getting IP address. I'm saying the portal. Access to the web. So I'm able to log in. So show security hotspot. Got one client connected. That's my PC. And if you want to see more, just hotspot clients, you can see more details because the portal has an embedded user ID. So I'm just going to do a pin test. And while we're doing the pin test, we do the failover. So if you look at the pin test value, it's really low. So it's really going through the WAN port. So what I'll do is I'll just stop one of the ports. The pin still continues. So I stopped one of the ISP link already, and the IP address is gone. So I'm going to stop another ISP link. My phone. So both WAN links are gone. So as you can see, the pin latency start to increase because we are on the LTE connection now, and both the WAN ports are also disconnected. So I'm just going to do another stop the LTE as well. Stopped one of the LTE, and my connection still goes on. I'm going to stop the other LTE, so I'm expected to lose connection. So straight away get request timeout. So that means the failover is really almost seamless. There's no packet drop when I failover between the WAN to the between the WAN and also between the LTE, and also from the WAN to the LTE. So now I'm just going to bring back everything. You just need to click connect. You will auto reset all the interface status. And everything is back again. As you can see, the latency now is very low. So I'm just going, and the LTE also start to come back. So that's pretty much all for today. And the failover works well, the multi-WAN load balancing, even with hotspot control. And if you don't have LTE, this tool is optional. And the two fixed line are working well with multi-WAN. If you have more ISP links, you just create another VLAN, assign another LAN port to that VLAN. Okay, that's all for today. Thank you very much for watching.